Well, hello guys, and welcome to the Campground channel. Today I'm going to discuss a very simple numerical problem which is related with the excess and limiting reactant. So the question is the carbonic acid here you can see can be made according to this reaction in which 1 mole of the carbon dioxide react with 1 mole of the water and it forms 1 mole of the carbonic acid. Now the question is, if 120 gram of carbon dioxide is dissolved in 80 grams of water, then find the limiting reactant. The second part of this question is find the amount of product, for example the carbonic acid which forms, and the third part of this question is, let me show you, the third part of this question is how much of the excess reactant is left unreacted. Before solving this question, let me give you an idea about the excess and limiting reactant. So the limiting reactant is the kind of reactant which consumes earlier in a reaction, and the amount of product which forms totally depend on the limiting reactant, or you can say the limiting reactant actually controls the amount of product which forms. Now the excess reactant is completely opposite to the limiting reactant. It is the kind of reactant which don't consumes completely in a chemical reaction, and some of its amount remains unreacted. Now the question is, we have to identify the limiting reactant in this reaction. So we can find this limiting reactant very easily. According to the balanced chemical equation, 1 mole of the CO2 reacts with 1 mole of the H2O. Let me show you this reaction again. 1 mole of CO2 reacts with 1 mole of H2O and it produces 1 mole of the carbonic acid. So according to this reaction, 1 mole of CO2 is required to react with 1 mole of the water, or you can say the ratio between the reactants carbon dioxide and water is 1:1. Now we are given the amounts of these reactants, 120 gram for CO2 and 80 grams for H2O. You can say, first of all, let's find the number of moles of carbon dioxide and water, and then we will compare these number of moles with each other, and the kind of reactant which will have smaller number of moles, that will be definitely a limiting reactant. And how we find it? We definitely find it by looking at the ratio between carbon dioxide and water. So first of all, let's calculate the number of moles of carbon dioxide. So 44 gram of the carbon dioxide is equal to 1 mole. Then how many moles will contain in 120 gram of the carbon dioxide? Okay, because 120 gram is the given amount of the carbon dioxide, so we get 2.73 moles of the carbon dioxide. So here in the question, 120 gram of the carbon dioxide corresponds to 2.73 moles of the carbon dioxide. Now let's find the number of moles of the H2O. You can see. So let me show you the second page. Okay, so now this is the calculation to find the number of moles for H2O, and here you can see that 18 gram of water is equal to 1 mole of water. Then how many moles will contain in 80 grams of the water? So what will happen here is the cancellation of these two similar units, and we are only left with the moles, and here we are only left with moles. So the number of moles of water which forms here is 4.4. Now the number of moles we have calculated for carbon dioxide is 2.73, but the ratio between carbon dioxide and water is 1:1. It means that for one molecule of carbon dioxide we need exactly 1 mole of water. If we have 2 moles of carbon dioxide, then we need 2 moles of water. The number of moles of water is higher than the number of moles of carbon dioxide, which simply means that water is an excess reactant while CO2 is a limiting reactant, because the number of moles of the CO2 is smaller as compared to the number of moles of the water. According to the balanced chemical reaction, for 1 mole of carbon dioxide we required 1 mole of water, but here in this case we have 2.73 moles of the carbon dioxide, but in this case we need 2.73 moles of the H2O to form 1 mole of the carbonic acid. But here in this case we have enough number of moles of the water which is greater than 2.73 moles, and it is equal to, you can see that the number of moles of water is equal to 4.4 moles. So this is an excess reactant while CO2 is the limiting reactant according to the balanced chemical reaction. So the total amount of the product which forms here is totally dependent on the limiting reactant, which is carbon dioxide. Now the second part of this question is what is the amount of product which forms. The first part of this question was to calculate the limiting reactant. Okay, the first part of this question was to find the limiting reactant and excess reactant, and we are done with that. We found the limiting reactant, which is carbon dioxide, and the excess reactant, which is water, and some of the amounts of water will remain unreacted, and we will find that amount later on. But let's focus our concentration on the second part of this numerical problem. The second part says that calculate the amount of product which forms, and I already told you that the amount of product which forms in this case totally depends on the limiting reactant. So according to the balanced chemical reaction, 1 mole of carbon dioxide which forms is responsible for producing 1 mole of the carbonic acid. So here we have 2.73 moles of carbon dioxide. So definitely according to this ratio, we know that it will produce 2.73 moles of the carbonic acid. Now in the next step, we just have to convert the number of moles of the carbonic acid to number of grams. So let me show you this page here. Now in the next step we just convert the number of moles of the carbonic acid into grams. So now let's calculate the molecular weight of the carbonic acid. We have 2 hydrogen atoms. The atomic mass of the 1 hydrogen atom is 1 AMU, so that's why we multiply it by 2, and I have written down the 2 here. Here the number of carbon atoms is 1, so we just write down the atomic mass for 1 carbon atom, which is 12, and then the atomic mass for oxygen is 16. We multiply it by 3 because here we have 3 oxygen atoms. We add these 3 values and we get 62 grams. So if now we know that 1 mole of carbonic acid is equal to 62 grams. Now we calculated the molecular weight of the carbonic acid. Now we have to convert the number of moles of the the number of moles of the carbonic acid into grams. So we know that the number of moles of the carbonic acid is 2.73 moles, and we multiply it by 62 because 62 is the molecular weight for 1 mole, or you can say for 1 molecule of carbonic acid. So we get 169.26 gram. Let me write down gram here. So the amount of product of carbonic acid which forms here is 169.26 gram. Now the third part of this question is how much excess reactant is left. Here you can see that how much excess reactant is left. Now the excess reactant in this case is water. We have found the number of moles of water already, which is total 4.4 moles of the water. So we know that 2.73 moles of water reacts with 2.73 moles of the carbon dioxide, while the rest of the amount of the moles of the water remains unreacted. So what we do here, we have to subtract the number of moles of water which reacts from the total number of moles of the water, which is 4.4, and here we get 1.67 moles of the water which remains unreacted. Now in the last step you just have to convert this 1.67 into number of grams. So 1 mole of the H2O is 18 gram. Then how much grams will contain in 1.6 moles of the H2O? The same unit or unnecessary unit cancel out each other in this case, and here we are only left with gram. So the amount of water which remains unreacted is 30.1 gram, which is the end of this numerical problem. If you find this video helpful to understand some of the basic concepts of chemistry, then subscribe to my channel and don't forget to give me a thumbs up. Thank you for watching and see you in the next class.